Welcome back. So let's look at the substitution method for definite integrals. So if we have a definite integral from a to b of f of g of x multiplied by g prime of x dx, notice that the integrand has two factors. One of them is the composition here of small f and g, and then the other factor is g prime of x, which is the derivative of the inside of the composition. And so when we have a integrand like this, then we substitute u for g of x, and then the differential of u will be used in place of g prime of x dx. And so then this integrand, then this integral simplifies to f of u times du, and the limits of integration also will change. So the new integral goes from c to d, where c is g of a. That is, remember that u is g of x. So when x is a, u is g of a. When x is b, u would be g of b. So d is g of b and c is g of a. So that's the substitution rule for definite integrals. So then once we then we know how to find this by applying the fundamental theorem and so on. So let's look at some examples. So let's say that here's the integral that I have, and so let's do the u substitution. We're going to take what should I pick for u? Well, my heart is going to do a better job than my head here, for example, because you look at x squared plus 3 to the 6, you wish that this was just an x, and if it were just an x, then you get x to the 6 here, and then you end up with the power of x in the integrand, which is easy to handle. So we're going to replace x squared plus 3 by u. So if u is that, then what is the differential of u? Well, that's that's the derivative of u, which is 2x times the differential of x. Okay, so then if I make this substitution, then what would be the new limits of integration? Well, when x is 1, u would be 1 plus 3, which is 4, and when x is 0, u would be 3. All right, so now let's substitute and get the new integrals. So notice that x squared plus 3 will be u, so we get u to the 6, and then 2x dx is going to give me du. So the 2x here together with dx will be replaced with du. So this is what we get, and the new limits of integration would be from 3 to 4. Okay, so now we know that the antiderivative of u to the 6, so now we apply the fundamental theorem of calculus. What is the antiderivative of u to the 6 with respect to u? Well, this is u to the 7 over 7. Now we plug in 4 and 3 and subtract. So we get 1/7, 4 to the 7 minus 3 to the 7. The 4 to the 7 minus 3 to the 7 is going to be 14,197. And that's the final answer. Okay, so let's look at another example. If we have the integral from -3 to 5 of 1 over root of 6 minus x dx, then what substitution should I be doing? Well, obviously the one that you would try here is replace 6 minus x by u. So let's do that. Or before I do that, I'm rewriting the integrand as 6 minus x to the negative half, which we can, because this is 1 over 6 minus x to the positive half, and then we can rewrite that as 6 minus x to the negative half. Now u is 6 minus x, so the differential of u would be negative. The derivative of 6 minus x is negative 1, so we get negative dx for du. So dx would be negative du, and so we make the substitution here, but let's change the limits of integration. So when x is negative, when x is 5, u would be 6 minus 5, which is 1. When x is negative 3, u is 6 minus negative 3, which is going to be 9. So we get negative. So where am I getting this negative? Well, that's because dx is negative du. So dx is replaced with negative du, and negative I'm keeping outside of the integral. New limits of integration would be 9 to 1, and then u to the negative half. The antiderivative of u to the negative half is u to the negative half plus 1, right? That's half. Negative half plus 1 is positive half, so we get u to the positive half divided by positive half, but that's the same as 2 times u to the positive half. So, I did a little bit different. So the negative here that I have, I can get rid of it if I switch the limits of integration. So I get 1 to 9 u to the negative half du, and then that's because the negative of the integral from b to a of f of u du is the same as the integral from a to b of f of u du. Now we can say, well, this is the antiderivative here is 2 e to the positive half. We evaluate the antiderivative at 9 and 1. So if I evaluate at 9, we get 2 9 root of 9. And if I plug in 1, I get 2 root of 1. So you get 2 root of 9 and 2 root of 1. I can factor out the 2. So root of 9 is 3. So 3 minus the 1 here is 2. So at the end, we get 4. All right, so let's look at another example. So we have the integral from 0 to 1 of x plus 2 over 3x squared plus 12x plus 5 dx. And okay, so what do we do here? Well, the question is, what substitution should I be making? In other words, what should I pick for u? Notice that the denominator is a quadratic and the numerator is a linear polynomial, and the derivative of a quadratic is linear. And so maybe try taking u to be the denominator and see what happens. So we're going to take u to be the denominator here, 3x squared plus 12x plus 5, and then the differential of u is going to be the derivative of u, which is 6x plus 12 times the differential of x. Now I'm going to factor out the 6 here, so that's going to give me 6 times x plus 2 dx. And one more step I'm going to do here is 1 over 6 du is x plus 2 dx. And the reason I did that is because remember that we have to write dx in terms of du. So to do that, I need this factor of x plus 2. So x plus 2 is right here, together with dx can be replaced with 1/6 du now. Okay, so the denominator would be just u. Now the new limits of integration, what are they? Well, when x is 0, right, x is going from 0 to 1. So when x is 0, notice that u would be 5. So when x is 0, u would be 5. When x is 1, u would be 3 times 1 plus 12 times 1 plus 5. So u would be 20 in that case. And so the new limits of integration would be 5 to 20. Notice that 1/6 du is replacing x plus 2 and dx, and then the quadratic here is u. So you get 1 over u. Now what's the antiderivative of 1 over u? Well, that's ln of absolute value of u. So we get 1/6 here, and then ln of absolute value of u. Now we evaluate the antiderivative at 20 and 5. So plug in 20, plug in 5, this is what we get. By using the laws of the logarithm, we get that the quantity in parentheses is the same as ln of 20 divided by 5, which is 4. So we get 1/6 ln of 4 as the final answer to this question. Okay, the integral from 1 to 2 of 5x to the negative 2 plus 4, and this does not need a u substitution. Notice that we can just apply the power rule for integrals to find the antiderivative here. So this would be 5 times, what's the antiderivative of x to the negative 2? Well, you add negative 2 plus 1, which is negative 1, so you get x to the negative 1 over negative 1, plus the antiderivative of 4 would be 4x. Okay, so that's the antiderivative. Now we plug in 2 and 1. So, well, okay, actually, so before I plug those in, let me simplify here. So this will be negative 5, and x to the negative 1 is the same as 1 over x. So negative 5 over x. Now we plug in. If I plug in 2, I get negative half, 5 half plus 4 times 2, and then minus. Now we plug in 1, we get negative 5 over 1 plus 4 times 1. All right, so now we do the arithmetic simplify. We get 13 divided by 2. So clearly you can see that I get an 8 here, and then I get a 4 here because I'm subtracting. So 8 minus a 4, that's 4. And then I also have plus okay, let's take a second here. So minus 5 plus 4, so I'm getting a negative 1 out of this parenthesis. So because of the minus here, I get a plus 1, and I have an 8 here, so 8 plus 1 would be a 9. So 9 minus 5 half here. So that's going to be 9 minus a 5 half, so that's going to be 18 minus 5 over 2, which is 13 over 2. Okay, so let me stop the video here. In the next video, we will be talking about the average value of a function. See you then.